Hey guys, so here's part 2 of the 2.6 notes. We're now going to talk about the rational zero theorem. So what this is saying is that every rational zero of a polynomial has the following form. So we have p over q. So what p represents is the factor of the constant term when we are in standard form, and then q represents the factor of the leading coefficient of our very first term. Now we need to talk about what rational numbers, real numbers, and complex numbers are. Okay, so let's talk about rational numbers. They are terminating or repeating decimals. So here are some examples of rational numbers. You have 1/2. Remember that makes it 0.5. Terminating means that you stop. Okay, now there we say 2/3. So that one is repeating, so it's always like 0.6666666. Okay, you can also have any numbers that are just integers or whole numbers. So like 0 is a rational, 1 is a rational number. Okay. And so on. So you could have like 0.75. That's a rational number. Okay, let's talk about real numbers. So real numbers, all numbers except imaginary. So remember, anything with I, that is an imaginary number. That is not real. So this can also include rational and irrational numbers, integers, and whole numbers. So we can have 0, -1, 5.5. We could have 7/9. We can have square root of 2, any type of number that you want. And that also includes pi, okay? Okay, lastly, complex numbers. So remember, this is actually all the numbers in the world. So these are real numbers and imaginary numbers as well, okay? So we could have 3. We could have 3i. We could have -4 plus I. Okay, we could still have square root of maybe 3. So it's any number that you can think of in the world. Okay. So what we're going to do here is find the possible rational zeros. Remember, rationals means numbers that are terminating or repeating as decimals, or they could be basically whole numbers or integers, using the rational zero theorem. So remember, what we want to do is we want the factors, or the numbers that multiply, first of our constant, and then of our coefficient on the first term. So our constant here on A, 3a is 12. That is going to be my P. Now my coefficient on the very first term, which x cubed is my first term, is going to be the 1. So that's going to be my Q. So let's think of all the numbers that multiply to 12. So we have 1, we got 2, 3, 4, 6, and 12, okay? Now, not only do the positive numbers multiply to that, but we also have to think of negative numbers. So actually in front of all of these, we're going to have a plus minus. 2, 3, 4, 6, and 12. Now what about 1? What are the numbers to multiply to 1? Just 1, okay? So now our last thing is we do need to simplify because we are thinking about rational numbers. So what we're going to do is take all the numbers that we see in the numerator and divide it by the numbers in the denominator. So we're going to take our 1, 2, 3, 4, 6, and 12 divided by 1. So we get plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, and plus minus 12. And that will be our final answer there. Okay, let's do that same thing for B. So we're going to find the rational zeros. Okay, remember decimals that repeat or terminate. Okay, now make sure, and I should have said this in A, that you have your polynomial in standard form. So if we look at B, we do have it in standard form, so we can go on and do this. So remember, we're going to do P divided by Q. So your P is going to be the constant. Remember, the constant is the number without a variable. Q is going to be the coefficient on your first term. So in this case, 3x cubed is our first term. 3 is that coefficient. Okay, find all the numbers that multiply to 4. So those are our factors. So that's going to be 1, we got 2, and we just have 4. Now, since 2 repeats, you don't need to write it twice. All you got to do is write it once. Now, what about for 3? Well, that's going to be 1 and 3. And don't forget to put a plus minus in front because you can also include negative numbers when you are multiplying here. Okay, now we got to take all the numbers to the numerator and divide it by all the numbers in the denominator. Okay, so we're going to take our 1, 2, and 4, and we're going to divide it by 1. So we get plus minus 1, plus minus 2, plus minus 4. Now we also need to take that 1, 2, and 4 and divide it by 3. So we get plus minus 1/3. That is a rational number because it repeats. We have plus minus 2/3. That also repeats. And then plus minus 4/3. And that also repeats. So you plug it into your calculator where you can see that. So these would be the possible zeros here. Now, what does it mean to be a possible zero? That means these could be the x-intercepts to these polynomials. Now, are all of them the x-intercepts? No, but they are possibilities, okay? So in the next video, you're going to see how can we figure out the actual x-intercepts to our polynomials. So make sure you watch part 3 of the 2.6 note.